then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great.
Tis the season to be serving.
When I was solving equations, I was feeling amazing.
Greetings, Precalculus students. Welcome to lesson 16. Today's lesson is pretty straightforward, pretty brief. This lesson is on something called end behavior. And as we know in mathematics, what we name things typically denotes what they represent. So end behavior represents what goes on the end of the graph from a horizontal standpoint for particular functions. And we're going to be looking at mainly, well, for right now, we're going to be looking at exclusively at polynomial functions. And the end behavior of polynomial functions is pretty easy to determine. So let's take a look at this. So again, this end behavior is a horizontal construct. So we're really just looking at what happens at the end of the far right of the graph and what happens at the end of the far left of the graph. So in this particular notations we utilize to signify this. And for instance, the right end, so what happens on the far right of the graph is denoted by x going to infinity. And that should make sense on a number line. As you go to the far right, the x value is tending towards infinity. Now, there are several things that can happen as x tends to infinity, but only two which are germane to polynomial functions. So I'm mainly going to look at the two things that will happen with polynomial functions, but I may mention the other things that could happen. So as we go to the far right of a graph of a function, polynomial function in particular, it's either going to shoot up towards infinity. So it's either going to shoot up like this, and that would be f of x tending to infinity. So this behavior would be written as x goes to infinity, the function f of x goes to infinity. Now, of course, the function going to infinity is going up to infinity. The function is like y, and it's a vertical construct. Of course, x is a horizontal construct. So either the function is going to go up to infinity, or the only other option is as x goes to infinity, the function shoots down. And so in this case, we would say f of x tends to negative infinity. And that's the same thing that can happen on the left. Here I'm looking at the right as x goes to infinity, but as x goes to negative infinity on the left, it's going to be one of those two things as well. Either the function is going to shoot up to infinity or the function is going to shoot down towards negative infinity. And that's really all we're going to see for polynomial functions. Now, for other functions, the function could level out on a constant at some constant value that typically occurs when you have what is called a horizontal asymptote. Or the function can oscillate between two fixed numbers, what happens when you have like the graph of sine and cosine. So there are some other things that can happen with more elaborate functions. But for polynomial functions, it's either going to shoot straight up or shoot straight down. So I just want to make mention of how it looks on the left end, even though the outcome is really the same, one of those two conclusions, but just to show it. So on the left end, this is where x is going to negative infinity. So that could be a little bit neater. So x going to negative infinity. So the right x is going to positive infinity. The left x is going to negative infinity. And again, one of two things is going to happen. Either the graph is going to shoot straight up, and so we say f of x is going to infinity, or the graph is going to shoot straight down. And in that case, we say f of x is tending to negative infinity as x goes to negative infinity. And that's really it. And in understanding of how the graph of polynomial functions work, make this extremely easy. We're going to present two types of problems to you. some problems where we give you the graph of the function, and other problems where we give you the function and you can graph it, or you can just analyze it from understanding how polynomials work. So let me describe to you exactly how polynomials work. So the graph looks something like this. And it will say describe the end behavior. And the end behavior is as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to infinity. And that's how you write the end behavior. Now, this is pretty basic. Again, both ends are going to infinity because both ends are shooting straight up. In fact, that's always going to be the case if the exponent is even and its coefficient is positive. If the exponent is even and the coefficient is positive, this will always be the answer. So this is always the answer where, so say my function is f of x equals a x to the n. This is the case where a is greater than 0 and n is even. So any function, if I give you the actual function and the x term of the highest power, so, and there can be some other stuff here, by the way. So there can be some other terms after this. It doesn't even matter. I'm referring to the leading term, so the term of the highest exponent. As long as its coefficient is positive and its exponent is even, the graph is going to look something like this. Now, if I add some other items, there may be little ridges. You know, a graph may start looking, you know, something like this, depending on the power. So you'll see these little ridges, but the end behavior is going to be unchanged. In fact, if you look at what I have graphed here thus far, let me add some additional things to it. So right here, a is 4. I have x to the 4th power. And I can add some items to it. Say I add minus 3x cubed plus 9x squared minus 2x plus 1. But that didn't really do much. So normally you'll see little grooves there. The values I chose didn't make much many things happen. So let me change the numbers up just a bit, just to have the graph have a little more excitement. Right now, it's a little bit misleading there. There's a little deal going on. So basically, it's trying to demonstrate that we can have little ridges, but the end behavior is the same. Now, when there was a 12 here, you may have get the impression that now the end behavior is different. You may be thinking that this left side is going to negative infinity. But again, if this highest exponent is even, that's not going to happen. So if you just zoom out, you'll see there's another part of the graph that is tending to infinity. So I stand by the fact that if this leading exponent, meaning the highest exponent, if it's even and its coefficient is positive, you're going to infinity on both sides of the ends. Both ends are going to infinity. Now, if it's even and its coefficient is negative, so I say put a negative sign there, and it may be difficult for you to see, but what happened, both ends are now going to negative infinity. And it's very difficult to see. Let me make the numbers a little more visible. So there you can see that the graph is going down to negative infinity. Again, it doesn't matter this. The deal is if the biggest exponent is even and its coefficient is negative, both end behaviors are going to go to negative infinity. So let me make a note of that. So the graph looks something like this. And again, it can have little ridges, just depending on what the other stuff is. But this is the case. So this is the graph of f of x equals a x to the n, where a is negative. So a is less than 0. And n is even. So the end behavior is going to be as x goes to infinity, f of x is going to negative infinity. As x goes to negative infinity, f of x is going to negative infinity. And you also saw there some of these, if you graph them, you got to zoom out a little bit to really see what's occurring. That's why it's more important to understand it by looking at the function itself versus trying to graph it. Because sometimes the graph could be a little misleading. So if I understand these rules of the coefficient of the variable to the highest power, it makes it a little bit easier. Again, sometimes the graph can be a little bit misleading. So the highest exponent is going to be one of two things. It's either going to be even or it's going to be odd. And its coefficient is either going to be positive or it's going to be negative. So we looked at both cases when the exponent is even. So now let's look at both cases when the exponent is odd. So let me go back to my graph. And so let me simplify the graph. So let me erase all this extra stuff for now. And let me make this positive again. And let me bring a little more of this graph into focus. And so now let me make this guy A an odd number. So let's say A goes from 3 to 11. And right now A is at 5. And you can see the graph. And this is all the graph here, so there's not a hidden part doing anything here. And this is typically how it's going to look for an odd power. So if I increase these powers, you see the graph is essentially the same. And even if the exponent was 1, just x, a linear guy, it would be a line, it wouldn't have these curves, but the end behavior would be exactly the same, meaning it would be going up on the right and going down on the left. So let's talk about that particular end behavior. So the graph looks something similar to this. And if you look at the end behavior, so I want to look at the right end behavior. As x goes to infinity, the function is going to infinity. And as x goes to negative infinity, so as x goes to the left, the function is going down to negative infinity. Now, this, of course, is the case of some function f of x equals ax n. And again, when I write the function as ax n, I'm understanding that there could be other stuff, after it, but the other stuff is irrelevant as far as its effects on end behavior. And this is where a is greater than 0 and n is odd. So when you have a polynomial and the highest power is odd and its coefficient is positive, this is going to be your end behavior. As x goes to infinity, f of x is going to go to infinity. As x goes to negative infinity, f of x is going to go to negative infinity. So it's going to be some agreement there. Now, if I happen to make this negative, So I kind of think you understand what happens when you make this coefficient a negative. So if I happen to make this negative, so notice how the graph is now. If I make it negative, this is going to happen. And so this is the case of f of x equals ax to the n and maybe some other stuff after it, where a is negative, so a is less than 0, and n is odd. And when this is the case, you have the following in behavior as x goes to infinity. So that's going to the right. So notice as I go to the right, the function is going down. So as x goes to infinity, f of x goes to negative infinity. And as x goes to negative infinity, so notice as I'm going to the left, the function is shooting straight up. So f of x is going to positive infinity. So that's the end behavior when the exponent is odd and the coefficient is negative. And really, that's all you really need to remember are those things, because you're going to be looking at polynomial functions. Now, again, sometime we're just going to give you the graph, and you should be able to analyze the graph. And then other times we're going to give you a function, and you should be able to analyze the function just from the way the function looks. I want to do just a couple of examples because sometimes the way the problems are written, the answer choices are written, sometimes it confuses people. So I want to look at a couple of examples quickly, just so you're familiar with how the problems look before you do them. Okay, so I'm just going to look at two quick examples to make sense of this. Now, this problem is a problem that has gave people some issues in the past because the way it's written. And so you should be able to deal with the way it's written if you understand what you're doing regardless. And the issue is this is somehow written a little bit like in reverse of the way we normally think of it. We normally think of it as x goes to infinity or negative infinity. What does f of x do? Well, this is written f of x is going to a certain thing as x goes to infinity or negative infinity. That sometimes confuses people. Don't let it confuse you. So this is what you do when you look at this problem. You look at the graph. So this is one where we're giving you the graph. And I think it's clearly that the left and the right ends are going to negative infinity. That's clear. So I need both of my f of x's to be going to negative infinity. That's what I need to see. And so that would be this answer choice. So if you look very closely, f of x is going to negative infinity as x goes to negative infinity. That's the left. F of x is going to negative infinity as x goes to positive infinity. That's the right. So pretty easy to discern. Sometimes people get a little confused on the answer choices. Look, every answer choice is going to have x going to negative infinity and x going to positive infinity. Every answer choice you see, all these x are going to negative infinity and all these x are going to positive infinity. It's the f of x's which are different because that's what you look at. And you know for this problem, both f of x should go to negative infinity. That's how we know it's A. I'm going to look at one more example because I don't want to spoil all the fun for you doing your assignment. And this next example, so I'm finding 3x cubed. Now, I could graph this if I want, and maybe if you need to graph it, go ahead and graph it. But I'm not going to graph it because I'm going to do an analysis of the function. The coefficient is positive and the exponent is odd. And I should know from what we just talked about, when that's the case, as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to negative infinity. So I'm looking to see that. So as x goes to infinity, I want to see infinity. That says negative infinity, not good. That says negative infinity, not good. These two say infinity. So C and D are looking nice. And then the other part should be as x goes to negative infinity, f of x should be negative infinity. Well, C says as x goes to negative infinity, f of x is infinity. So it has to be D. If you look at D, as x goes to negative infinity, f of x is negative infinity. So that concludes in behavior. Again, in the past, this has given some people some issues. We'll see how you do. It's pretty basic once you get the hang of it. And so hope you have fun on your assignment, and we'll see you next time.